Greetings to Madam. Today we are going to present our project, which title is Event Ticketing System. Here are my fellow team members, which is me, Delson, as the group project leader, Ouyang Jinan, Tan Boon and Tan Heng. Now let's look at the introduction part. For introduction, we divided into 5 parts of entities, which is user, event, ticket, booking, and payment. And as for user, there are 3 types of users, which is customer, employee, and admin. And each user has their own unique user ID, and customer must register before purchasing tickets. As for event, there are many different types of event, such as exhibitions, concerts, sports, or others. And each event also has their own unique event ID. Ticket. Each ticket has a unique ticket number, and each of them represent one seat for an event. And this ticket includes price and type, and only can be sold at once. For booking, user can book one or more than one tickets, but each booking is belong to only one user. As for the booking includes also included date and total amount. As for payment, each payment has a unique payment ID and is linked to booking. It includes payment method, amount, and status. And now we are going to talk about the problem statement and objective. The first problem statement is traditional method, which cause people for inconvenience. This is because people need to wait and queue for a long time and need to wait for a long queue to buy for the ticket. And for the objective, we develop an online system which is more convenient for people so they can buy ticket easily through online. And the second problem is there are no data management system, which the event information and cannot be stored efficiently. So to solve this problem, we provide a centralized database system for managing events, tickets, and booking information more efficiently. And the third one is about data inconsistency and loss of data will be occurred in this part. So to avoid that, this system we ensure that the data consistency increase and accuracy rate also increase. And the last one is it's unable to search for the data and record accurately. So it's very hard to look back for the record of the customer, like booking or make some payment record. It's very hard to search for the record. And so we develop an event ticketing system which help in searching information about their such as payment records and their information of bookings. And next, my team member Owe will talk about his point about his ERD.
Good afternoon, madam. My name is Ouyang Jian. For me, I will explain about the ERD for our system. For our ERD, the first entity is user. In this user entity, it contains a user ID as a primary key, and also other attributes like username, user phone, and many more. For this entity, it has a many-to-many relationship with the event entity. For this event entity, it contains a event ID as primary key and other attributes like event name, date, time, and many more. Due to this is a many-to-many relationship, so in the middle, we create a composite entity and name it as booking. And inside this booking entity, it includes a booking ID as the primary key and user ID and event ID as the foreign key that link to the user and also event table. Next, for booking entity, it also has a one-to-one relationship with the payment entity. For this payment, it contains a payment ID as a primary key and also a booking ID as the foreign key that link to the booking. For this booking and event entity, both have a one-to-many relationship that connect to ticket entity. For this ticket entity, the ticket ID is the primary key and the booking ID is the foreign key that link to the booking. So now let's move on to the next part, normalization. For first normal form, we must ensure that no repeating group. So we put all the user, event, booking, payment, and also ticket information into a big table and then it as the ticket system. To achieve the second normal form, we must remove the partial dependency. From the first normal form, we found that there are a few partial dependency. For example, user information depend on user, event information depend on event ID, booking information depend on booking ID, and payment and ticket information each is depend on payment and ticket ID. So to achieve this second normal form, we remove this partial dependency and we decompose this one single table into 5 tables, which is user, event, booking, payment, and also ticket table. Next, for the third normal form, in the previous second normal form, we found that there are a transitive dependency, which is ticket price depend on ticket type. This ticket type that can divide into adult and also children. So the price for each type will be different. To achieve this third normal form, we must remove this transitive dependency. So we will decompose the ticket table into 2 tables. The first one is the original table, ticket, which contains ticket ID, primary key, seat number, and a booking ID from foreign key. And the second table, which is the new table, is ticket type, and the ticket type is the primary key, and also the ticket price in this table. So that's all for my part. Thank you.
Hello everyone, I'm Tan Boon Xian. Now I will take part of the presentation about data dictionary of our event ticketing system. We have created 5 major tables in this system, including users, event, booking, payment, and ticket. This table will respectively perform their task to manage and sort the data stored in the database. First of all, in users table, we have created user ID, username, their phone number, email address, password, as well as the account register date. The register date will automatically store as the time they register a new account. The second table is event. It includes all information about the event, such as the ID, event name, event status that shows whether it will be held or unavailable. Furthermore, the table also includes the date and location of the event held, as well as the event starting time and ending time. For Table 3 booking, it includes the booking ID, booking date, and the amount paid by the user for booking purposes. This table is also associated with user ID and event ID as references. Next, in the payment table, it includes payment ID, payment date, the amount of the payment, and the payment method used. Besides, the payment status in the table is represented by 0 or 1 to show whether the payment is completed. We also put booking ID into the table as a reference. Finally, in the ticket table, it contains ID, type of the ticket such as the ticket for the children or adult. And most importantly, it contains ticket price, which matters the most to the users. Likewise, we also use booking ID as the foreign key in this table. Next, let me do a quick and basic demonstration for our system. Alright, let's start to create 5 tables that I mentioned before. First, we log into the MySQL. Since our system is called Event Ticketing System, I will just use the short form as ETS. Then I will create the first table, table users, the second table, table event, third table, table booking, the fourth table, table payment, and the last table, I make a bug inside, which is I didn't put the foreign key that I mentioned before, but now I will perform the outer table to make it normal. So I will add a column first, outer table ticket, add booking ID, not now, so that the table contain the column. Then I will make it link to another table using the foreign key. The outer table add constraint and put a new name for the foreign key as the constraint name. Then I will put the on delete restrict and on update cascade. Next, I will put the every values into the table to see that the table can perform well. Let's select the first table from users. All right, select the table from event. Yeah, select the table from booking and select the table from the payment. And most importantly, select table from the ticket to see whether the foreign key can perform. Yeah, it's already inside the table. For basic TML command, it includes select, insert, delete, and update. For the first one, I will select from booking where user ID is equal to U00004. So the output is all user ID equal to U0004. For the second one, I will select event ID, event name, event date from event order by event date in ascending order. So the event name will according to the event name order, event date order. For the third one, I will insert a value into the event table. So we select from event table. It will come up a new event ID and event name, but with no value behind. Next, I will perform delete from ticket where ticket ID is equal to T004. Let's select from ticket. So as you can see, the 004 already been deleted. Next, I will perform update. Update ticket, set ticket price as 85, where ticket ID is equal to 7. Let's select from ticket. Yeah, so the ticket ID 80 ringgit to 85 ringgit. So that's all of the basic command to create a table with the following functions. Next, the advanced function will be covered by our last members. Thank you.
Hello everyone, I'm Bentley. Now I will continue the demonstration part. We can use the join element to find all users who book a specific event. With select username, user phone, event name, and booking date from booking, join users on users ID in booking tables equals to user ID in the users table. Join event on event ID in the booking tables equals to event ID in the events table, where event name equals to fun run 2026. And the output just like this. Next, we can use having statement like select booking ID from ticket, group by booking ID, having count ticket ID larger or equals to 2, and the output just like this. Next, we can use the group by statement, and the output will become this. It is grouped by the event name. Next, let's talk about the sub-query statement. We can find the users who book events is costing more than 100 with the command select username from users, where user ID in select user ID from booking, join ticket on booking ID in the booking tables equals to booking ID in the ticket tables, group by booking ID, and having some ticket price is larger than 100, and the output will become this. Now I will create a view names booking summary with create view booking summary as select booking ID, username, event name, booking date, booking amount paid from booking, join users on user ID equals to user ID in the users table, join event on event ID in the booking tables equals to event ID in the event tables, and the view will be created successfully. Now let's check about the view with select from in summary. And the output is just like this. Next, we'll talk about the window function. As a code, select payment ID, payment amount, and rank over with order by payment amount descending as payment rank from payment. The output will become like this. It will show the payment ID, payment amount, and the payment rank. The payment ID and payment amount will be ranked with the descending order of the payment amount. Next, I will talk about the trigger. I will use this code as create trigger at payment amount. It means if we insert a new data into the payment table, the booking table will also be updated. As the example, we check the booking table first. Now, booking ID B00001, the booking amount paid is 120. If we insert the payment values into the payment table, let us check the payment table first. Alright, the payment ID, new payment is already be created. And now we check the booking table. Look, just like this, the booking ID with B00001, the booking amount paid is become 180. Next, the store procedure. I will use this code we created procedure at payment to call this code. I will use the call at payment with the new data I need to insert it. We check for the payment table. Look, the new data is already been inserted. For the transaction statement, I will type the code with start in transaction and insert into payment values with the new data I want to insert. Use the transaction statement. We can make sure the error data will not be input into the database. If there is no error, we can type commit to insert the data. We check the payment table again. Look, the data is already been inserted here. For the last, let's talk about the optimization statement. Let's type the create index IDS booking users on booking user ID, and the index is created successfully. How we check it? I will use show index from booking, and here, IDS booking user already be created for the user ID in the booking table. That's all for the demonstration part. Thank you.
So as for conclusion, our system has successfully achieved its goal by providing a centralized database system for managing events, tickets, and bookings information more effectively. Therefore, data inconsistency and duplication are also reduced efficiently, and it also increased the data of accuracy about event informations and their customer payment records. So in future, we will focus on improving the system features such as seat selection, attendance monitoring, and some promotions to improve the system user experience, usability, and offer a smooth performance for users. And that's all. Thank you.